Polygons are given names relative to the number of sides. We start with the triangle, 3 sides, quadrilateral, 4 sides, pentagon, 5 sides, hexagon, 6 sides. Heptagon, sometimes called septagon, has 7 sides. Octagon has 8 sides. Nonagon with 9 sides. Decagon, 10 sides. I know of no special name for an 11-sided polygon, sometimes called just an 11gon. But a 12-sided polygon is a duodecagon, and after 12 sides, we often just call polygons n-gons, where n is the number of sides. But I do know one more polygon with a special name. A 15-sided polygon is a pentadecagon. We go back to our triangle. It has 3 angles, and we know that the sum is 180 degrees. Here's a quadrilateral, which may also be a parallelogram, but it can be divided, as shown by the blue diagonal, into 2 triangles. And the 6 angles shown in red from the 2 triangles add up to the 4 interior angles of the quadrilateral. So if the sum for each triangle is 180 degrees, the sum for the whole quadrilateral is 360 degrees. In a pentagon, it can be divided into 3 triangles as shown. So each triangle has a sum of 180. There's 3 of them. 3 times 180 is 540 degrees, which is the sum of the 5 interior angles of a pentagon. In a hexagon, we can get 4 triangles, and 4 times 180 degrees is 720 degrees. So 720 degrees is the total of the sum of the 6 interior angles of a hexagon. And that leads us to Theorem 55. The sum of the measures of the angles of a polygon with n sides is given by the formula that the sum, S, is the number of sides take away 2 times 180. And now we're looking at a triangle, and the 3 interior angles are marked in blue, and at each vertex 1 of the exterior angles is marked in red. So we have 3 linear pairs. Each linear pair consists of a blue angle and a red angle. And we know a linear pair totals 180 degrees. They're supplementary. So 3 supplementary pairs is 3 times 180, or 540 degrees. And of course, the sum of the 3 blue angles is 180. So if we do 540 minus 180, we get 360 degrees. And what that tells us is the 3 red angles, or the 3 exterior angles, have a sum of 360 degrees. We do the same thing for a quadrilateral. Now we have 4 linear pairs. 4 times 180 is 720. The sum of the 4 red angles in the quadrilateral we know is 360. 720 minus 360 is 360. So the sum of the 4 blue exterior angles is 360. We go to the pentagon. Now we have 5 linear pairs. 5 times 180 is 900. We know that in a pentagon, the 5 interior angles, here shown in red, have a sum of 540. 900 minus 540 is 360 degrees, so the 5 blue exterior angles have a sum of 360 degrees. And that brings us to this Theorem 56. If one exterior angle is taken at each vertex, the sum of the exterior angles of a polygon is given by the formula S for sum is equal to 360 degrees. It's an interesting formula because it's just the constant 360 degrees. It applies to all polygons. And now, an official definition of the word diagonal, a word we've used several times. A diagonal of a polygon is any segment that connects 2 non-consecutive, also known as non-adjacent vertices of the polygon. We already know that triangles don't have any diagonals. So there's the 2 diagonals in a quadrilateral. And there's 1, 2, 3, 4, 5 diagonals of a pentagon. And 1, 2, 3, 4, 5, 6, 7, 8, 9 diagonals in a hexagon. And we can summarize: triangle, no diagonals; quadrilateral, 2 diagonals; pentagon, 5 diagonals; hexagon, 9 diagonals. And let's do one more, the heptagon, also known as a septagon, a 7-sided polygon. We'll start at a vertex. The vertex, of course, can't be connected to itself. And we don't connect it to the 2 adjacent vertices because they're already connected. But those are not diagonals. Those are sides of the polygon. So let's get started. There's 1, 2, 3, 4. So from each vertex, we can find 4 diagonals. Let's go to another vertex. 1, 2, 3, 4 more to make a total of 8. And now another vertex. There's already one there that came from our original vertex, but there's 3 more. Brings our total to 11. We go to yet another vertex. We already see there's 2 already there, so we can get 2 more. Brings our total to 13. We go around to one more vertex that already has 3. There's 1 more, and the final 2 vertices already have their 4 diagonals drawn. So for a heptagon, the number of diagonals is 14. And that brings us to this formula. The number of diagonals that can be drawn in a polygon of n sides is given by the formula. Take the number of sides and multiply it by the number of sides minus 3, and then divide by 2. In this lesson, we looked at Theorem 55. The sum of the measures of the angles of a polygon with n sides is given by the formula n take away 2 times 180. Theorem 56. If one exterior angle is taken at each vertex, the sum of the exterior angles of a polygon is given by the formula that the sum is equal to 360 degrees. And finally, Theorem 57. The number of diagonals that can be drawn in a polygon of n sides is given by the formula n times n take away 3, all of that divided by 2.